Hey everybody, so in this video we're talking about solving quadratics by completing the square, and with these examples a is going to be greater than 1. So in a prior video I did multiple examples but a was equal to 1. So remember, the idea here is to create a perfect square trinomial. Now that can only happen when a is equal to 1, and in these examples a is not 1. So what do? Well, we're only adding one step, and the idea is let's make a equal to 1. So if this is 2x squared, how could I make this 1x squared? Well, I could divide by 2. Well, you can't do something to just one term, so let's divide every term by 2. That includes the 0 or the constant on the other side. So now I have x squared minus 4x plus 3 equals 0. Now I have a equal to 1, and here what I can do is I can now solve this by creating a perfect square trinomial. So here if I took negative 4 and cut it in half, I get negative 2. Negative 2 squared is 4. I want 4 to be the value of this number, not 3. So we're going to do like we did in prior videos. We're going to move the 3 to the other side. And now we get x squared minus 4x equals negative 3. So here, cut it in half, negative 2, square it, that gives us 4. So we're here going to add 4 to both sides. And now we need to factor our perfect square trinomial. So what are the two factors of 4 that I can add and get negative 4? And that would be minus 2. So here I have x minus 2 quantity squared equals 1. And now I can solve using the square root method. So now I have x minus 2 equals plus or minus 1. Now I can add 2 to either side. And my solutions here are going to be 2 plus 1 and 2 minus 1. Here, let's try this one. Now, you know we need this to be 1. So I need to divide everything by 5. But before I do that, pay attention to every number. If I divide 34 by 5 or 6 by 5, am I going to get a whole number? No, I'm not. So it may be easier to move the constant first, then divide by 5. So let's do that. So here I'll add 34 to both sides. And now let's see if every term is going to be divisible by 5. So here we have 5x squared plus 10x equals 40. And now I can divide by 5 and it won't really be a problem. So I'm going to go through on every term and divide by 5. And now I have x squared plus 2x. This is going to equal 8. Now here I can take 2, cut it in half and square it, and that's going to give me 1. And I'm going to add 1 to both sides. And now I can factor my perfect square trinomial. So here I have x plus 1 quantity squared equals 9. I can solve by square roots. And now I can subtract 1 to solve for x. So now I have negative 1 plus or minus 3. So here x is going to be equal to negative 1 plus 3 and negative 1 minus 3. Now, what I want you to do is I want you to try our third example by yourself, because you may notice something a little different. If I go ahead and divide by 4, I get a whole number, 1. I get a whole number, 2. I get 3/4. But even if I move the 3 over here, I'm still going to work with the fraction. That is 100% okay. We've worked with fractions since elementary school. So pause the video, try this one, and then hit play to check your work with mine. So here, dividing by 4 on the first or second step really isn't going to make a difference. You're still going to wind up with a fraction, which is fine. So here we have x squared plus 2x, and I'm going to go ahead and move the 3/4 over here. So this is going to equal negative 3/4. Now we have a similar problem we had right over here. X squared plus 2x, x squared plus 2x. So if we cut this in half and square it, we know it's going to be 1. I'll still add it to both sides. Now we want to factor this perfect square trinomial. So we know this is going to be x plus 1, quantity squared, equals, and now all we're doing is just adding fractions. So remember, the easiest way to do this is with common denominators. Luckily, this number is 1, and you can rewrite 1 an infinite number of ways. So I'm just going to make it 4 over 4. So negative 3 plus 4 is 1, so this is 1/4. And now solving with square roots isn't going to be an issue, because we know when we do the square roots with fractions, we're taking the square root of the numerator and the square root of the denominator. So here I have x plus 1 equals plus or minus 1 over 2. Now I can subtract. So x is negative 1 plus or minus 1/2. So here x is equal to negative 1 plus 1/2 is negative 1/2. And negative 1 minus 1/2 is negative 1 1/2, or negative 3/2. All right? Now, let's take a look at a few examples where our solutions are not going to be integers or rational numbers. All right? So the first thing we always want to try is to get a equal to 1. So I want to check, can I go ahead and divide all of my numbers and get integers? Yes, I can. So it's perfectly fine to go ahead and divide all of this by 2. So this is going to give me x squared minus 8x plus 11 equals 0. Now, this is not a perfect square trinomial because I want to cut this in half and square it. So I'm looking for 16, not 11. So let's go ahead and move the 11 over here. So we know this should be x squared minus 8x, and I want this to be 16. And here, this will be negative 11 plus 16. So negative 11 plus 16, this is going to give me 5. And I'm going to factor my perfect square trinomial. So here I have x minus 4, quantity squared, equals 5. Now I can solve using square roots. So I have x minus 4 equals plus or minus the square root of 5. I can now add 4 to both sides. So here, x is going to be 4 plus or minus the square root of 5. All right, here in this example, can I go ahead and divide by 4 and get all integers? And that answer is yes. So I'm going to divide everything by 4. So here I'll just do one line instead of 3 little lines. So here, divide everything by 4. So this is going to give me x squared plus 10x minus 3 is equal to 0. We know this is not a perfect square trinomial, so we'll go ahead and move the 3 over here. So I have x squared plus 10x equals 3. Let's go ahead and cut 10 in half. That gives us 5. 5 squared is 25. And what we add to one side, we will add to the other. All right, here we need to factor our perfect square trinomial. So this is going to give us x plus 5. And then we're going to solve by taking the square roots. So here I have x plus 5 equals, again, remember for this is totally up to your teacher. You can simplify the radical. You do not have to be numerically correct. I will do it for the purpose of this video. So this is going to be plus or minus 2 root 7. And then I can subtract. So here, my answers are negative 5 plus or minus 2 root 7. All right. Go ahead, like the last 3 examples, pause the video and you try this last one on your own, and then you can unpause and make sure we have the same answers. So here, I'm going to go ahead and divide every number by 3 because I want a to have a coefficient of 1. So this would be x squared minus 2x minus 1 equals 30. Now, is this a perfect square? If I cut negative 2 in half, I get negative 1. Negative 1 squared is positive 1. All right, not negative 1. So this is not a perfect square trinomial. The 1 now must go. So now I have x squared minus 2x. That should be a positive 1. And here, this is going to be 31. Remember, I kind of skipped some steps here. I moved the 1 over. That gave me 31. And then I cut this in half, and I squared it. That's where the positive 1 came from. Now I can factor this. I'll solve by taking square roots. And then I will isolate the x by moving the 1. So here my solutions are going to be 1 plus or minus the square root of 31. And that is how you complete the square anytime a is greater than 1. That's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.